in this lesson, we'll learn about the data structures in R. What are data structures? They are the way we organize, we store, and manage data in R. Let's just think of them as a container or an object where we keep things and where we keep them tidy so we can access them easily later. We can liken data structures to some of the objects we are used to. An example is our school bag, where we can store our stationery, our laptop, and also books. Another example is a bottle, and a bottle ideally should only contain liquid. That's also a data structure, storing liquid. We have our mobile phones, which is a storage for all form of digital assets which we have, and digital data and information which we have. There's also another one which is not here, the cloud. It's also another form of storage. Yeah. Another example is the book. Our books store text information. Now, what are the types of data structures? We have 5 types of data structures. It includes the atomic vector, the matrix, data frame, lists, and arrays. Of the 5 types, we are going to discuss only 4: atomic vector, matrix, data frame, and lists. And we won't be discussing arrays. Now to atomic vectors. We are actually quite familiar with atomic vectors. They are the simplest form of data structure. And if you remember, in the data types class, we created different atomic vectors. An example is this fruit variable, which we've just created. This fruit here is an atomic vector. And to confirm if it's indeed a vector, you can use the is.vector function. And this shows that yes, it's true, it's a vector. Another example is this simple vector, which is a scalar vector, the simplest of its form. It's assigning the value 6 to the variable 6. So this here is also another vector. This means that vectors are usually one-dimensional. As we saw earlier right here, what we did is we combined different elements using the C function. I do hope you remember the data types, because the data types are the atomic vectors, and they include characters, double, integer, logical, and factor. Another example to make us understand vectors better is a bead. This bead is a single color bead, as we do have beads that are multiple colors, but this bead is a single color bead, meaning that atomic vectors only hold a particular data type, just one. Also, we have this train here, this long train. This looks like Switzerland, maybe not. Yeah, but this single colored train is also another visual aid to help us remember what atomic vectors are. Now to matrix. Matrix, they store values in 2 dimensions, and the values are usually stored in rows and in columns. An example is a crate of egg. And one thing about crate of eggs is that crate of eggs should only contain eggs, which means that matrix only store a single data type too, but is having 2 dimensions. For this crate of egg, we have 1 column, 2 column, 3 column, and 4 column, like that. And we have 1, 2, 3, 4, 5 rows. So we have 4 columns, 5 rows. And to mention this, we have what? A 5 by 4 crate of egg. To continue, another example is the calendar. And one thing with calendar is that they are usually checkered like this, and they are also organized in rows and in columns. So to test you, what is the dimension of this calendar matrix? The answer is 1, 2, 3, 4, 5, 6. 6 rows. 1, 2, 3, 4, 5, 6, 7, and 7 columns. So it's a 6 by 7 matrix. To data frames, if you are familiar with Microsoft Excel or LibreOffice Calc, then you are familiar with data frames. They also store values in 2 dimensions, like matrix, and they are quite useful. They are actually the most used form of data storage for data analysis. This is because they can store different types of data, not just a single data type like matrices or a single data type like atomic vectors. They can store different data types. And the way they do this is to store a single data type in a column. So you store a single data type in a column, in another column, you store another data type. And an Excel spreadsheet is a good example. Another one is a class attendance, where you have your name, then you have your attendance if you are present or absent. The name is usually a character. Then present or absent can be a symbol, which can be a tick or can be signified using 1, 2, 3. Lastly, to lists. Lists are actually like atomic vectors, but they are atomic vectors with superpowers. And that's because they group objects together instead of values. Atomic vectors store values and can only contain one data type, while lists, they store objects. This implies that what? Lists can store data frames, they can also store matrix, they can store atomic vectors. So list is like a storage for everything. So a good example of list is our school bag. Our school bag can contain our water bottle, it can also contain books, pen, and other different things that fit into your backpack. Another one is our lunchbox. Our lunchbox contains different type of food, fruits, sausage. This is actually a fancy lunchbox, nuts, but different types. And also our wallet. Our wallet contains identification. Some people add money in there. Some people put some little pen in there, and some actually put their pen drive in there, and some store paper in their wallet. Different things you can store in this small thing. Now, a short teaser to round up this lesson. The shipping container that we saw in the introduction. Which type of data structure do you think it is? And also, a book. Under which data structure would a book fall under? And your mobile phone, which you are using, under which data structure? Yeah. See you in the next lesson, where we'll see how to create and manipulate the different data structures in our programming.